All right, so we're going to start by balancing, and then we got H, S, O, and Na, and we counted 3, 1, 5, 1 on the left side of the arrow. Okay. Okay, we want to count the elements on the right side of the arrow now. So let's go to the right side. If you take a look at Na, how many Nas do we have on the right side? 2. Good. Okay, how many S's do we have? Yeah, just 1. There's no number behind S, so it's going to be 1. All right, let's go to the oxygens. If you go to oxygen, there's 4 here and 1 here. So how many total do we have? 5. Perfect. And then last one for hydrogen, we got 2. Okay, so that's how you can count up the elements on the sides of the arrows. Okay. Make sure you're just careful when they're split up like this. You want to make sure you add them all together. Okay. All right, so if you take a look at the elements, which one's the one that's not balanced? Yeah, hydrogen is not balanced, right? On the right side. We need more hydrogens on the right side. So we have to add H to the right. Okay, so the only way we can do that is by adding the molecule that's already there. So we're going to put H2O. Okay, so if we do that, that's going to change up our numbers, right? So another way you could think about counting these elements is if we add H2O, how many H's did we add? Not 1, 2. Yeah, we added 2. So that means we can just add 2 to this number. So we have a total of 4 H's now because we added 2. Okay, and if we added 1 oxygen, that's going to be plus 1 more. And that's going to be 6. So now we have 4 hydrogens and 6 oxygens. Okay. Does that make sense? That's another way that you guys can count the elements. If you add H2O, you add 2 H's, 1 O. So you can add 2 H's and 1 O. Okay. Okay. Our H's are still not balanced, but now the left side needs more H's, right? So if we take a look at these 2 molecules, they both have H, right? But one of them is a better choice to add. Which one do you think is a better choice to add? That one is this one? Yeah, it's going to be this one. And that's right. And it's because this one has Na, O, and H. And if you look at the ones that are not balanced, it's Na, O, and H. So this is the right one to add. So you always want to look at the other elements before you choose what to add, especially if the elements are split up. So we're going to add NaOH. So you add 1 more Na. That's going to give us 2, and this balances out. Okay, if we add 1 more O, that's going to give us 6, and so this balances out. And then last one, H, we add 1 more. That's going to give us 4. And now everybody is balanced out, and we're good to go. Okay, so we're all good now. We're just going to put the numbers in the front. We got 1 of these. We got 2 NaOHs. We got 1 of this, and we got 2 H2Os. Okay, so that's how you balance the chemical equation. Okay, and the one on your lab and the rest of the assignment, they're going to be pretty similar difficulty, not too crazy. Again, if your numbers start getting too big, you messed up somewhere, so you want to probably go back and fix up your numbers, okay? It's not going to go to like 5 or 6 or anything like that. All right, any questions on the balancing? Okay, so let's move on. So that's the balancing equation. That's the first thing that you want to do for every single one of these stoichiometry problems. And now we're just going to finish it up, okay? Okay, so in your lab, basically what I'm going to do is I'm going to give you guys a certain solution, and then you're just going to want to make a solution that reacts with it, okay? So let's take a look at this problem and look at all the numbers, and we're just going to organize the numbers by putting it with the chemical that it corresponds to, okay? So let's just go through the question together and organize our numbers. So it says, suppose that your teacher has a 50 mils of a 1 molar H2SO4 solution, okay? So let's stop right there. Okay, we got 2 different numbers, and we got to make sure we put it with the right chemical, okay? So 50 milliliters, which chemical is it talking about out of these 4? 50 mils. Which chemical does 50 milliliters pertain to? Yeah, this one right here, right? H2SO4. It's 50 mils of H2SO4. So 50 milliliters is going to correspond to this chemical right here. Not that one. This one right here, H2SO4. Does that make sense? It's just reading comprehension, just whatever it is talking about, that's what we're looking at. Okay, and then 1 molarity is going to talk about the same chemical. It's going to also pertain to H2SO4. Okay. So first thing you want to do is organize your numbers. That way you don't switch them up. For my honors class last period, we still have people switching up the numbers and the chemicals. So just make sure that you guys label it in the very beginning. That'll keep you guys organized so you guys don't make those mistakes, okay? Okay, and then it's asking you want to react all the H2SO4 with 250 mils of a NaOH solution. So this one is obviously talking about NaOH, right? So NaOH is going to be 250 milliliters. All right, and then lastly, what does the molarity of your NaOH solution have to be? So if it's asking what does, that's what you're looking for. So at the very end of the problem, you're going to be looking for molarity of NaOH. Okay. So we've organized all our numbers, and we know what we're looking for. We're looking for molarity of NaOH. Okay, so let's take the numbers that we start with and figure out our final answer. So if you guys take a look at our numbers, we have 50 mils and 1 molarity for H2SO4. That's what we're going to start with, okay? Now, if you guys remember, we've been using this formula for the last like 3 weeks now. Molarity is moles over liters. Okay, and let's talk about H2SO4. Now, it's 1 molarity, so I'm going to put 1 molarity right here. We don't have moles of H2SO4, so we're going to put moles. And then on the bottom, we need to put liters. The way that we go from milliliters to liters is we divide by 1,000, and that's going to give us 0.05 liters. So we put 0.05 liters on the bottom. Okay, so again, this is the same thing that we've been doing. Hopefully, you guys are pretty familiar with how to solve this. So I'm going to give you guys 1 minute, see if you guys can pull out your calculator and find out what the moles of H2SO4 are. Use this equation to basically solve for moles of H2SO4. I'll give you guys 1 minute to do that. We'll go over the answer, and we only have like 1 or 2 more steps for this part of the question, okay? Take a minute to solve that. Okay, so for the moles of H2SO4, the way that you solve it, if you guys remember, just regular algebra, you're going to multiply by 0.05 on both sides, because if you do that, this cancels out. All you're left with is moles of H2SO4, and then all you got to punch into your calculator is 0.05 times 1, which is equal to 0.05, and that's going to be your moles of H2SO4, okay? So if you want to find moles, just multiply by the liters on both sides, and this should cancel out. Ah, bless you. Ah, bless you. Okay, so now that we have 0.05 moles of H2SO4, what we're going to do is we're going to turn it into the chemical that we are looking for, okay? So hopefully by now you guys are familiar with doing that. We're just going to set up a fraction. Okay. And since we're trying to get rid of moles of H2SO4, we're going to put moles of H2SO4 on the bottom. And on the top, we're going to put moles of NaOH. So we're going to put moles of NaOH. Okay, since we have moles and moles on the same fraction, we're going to get the numbers from the chemical equation. Okay, so we just got to look for these chemicals. If you look at NaOH, it has a 2 in the front, so we're going to put a 2 right here. If you look at H2SO4, there's a 1 in the front, so we put a 1 right there. Okay, so again, same thing that we've been doing. Since there's moles and moles on the same fraction, we get the numbers from the equation. Okay, and I'll do the math for you guys just to keep it simple. You just do 0.05 times 2, and that'll give you 0.1 moles of NaOH. Alrighty, guys. And then last step, we still need to turn this into molarity of NaOH. So we're just going to use the molarity formula one last time. So if we're looking for the molarity of NaOH, we put moles of NaOH on the top, and then we just divide it by the liters. So we just found the number. So it's 0.1 on the top, 0.1 moles of NaOH. And then we're going to divide by the liters, which is 250 milliliters. So we just divide that by 1,000. That's 0.25 liters. And that's going to give us our final answer. So I'll give you guys another minute to punch this into your calculator. See if you can get the final answer for part A. And then you guys will be all done. And we're ready to move on to part B. Okay. Okay, so we're going to put 0.1 on the top, divide by 0.25, and that'll give you a final answer of 0.4. So your answer is going to be 0.4 molarity NaOH. So this is the strength or the concentration of the solution that you want to make. Okay. All right, so part B for this assignment, and you're going to be doing this as you prep for the lab. You're going to be writing your own procedures for making the solution, and we went over this in a previous assignment, so I'm just going to go through it very briefly. These are the 5 steps you're always going to need, but I'm going to show you guys how to fill in the blanks with the numbers that you need, okay? So first step is you want to get a certain size volumetric flask. Now, the flask size always depends on the chemical solution you're making. So here we're trying to make NaOH. And so if you take a look at NaOH, the size that we want was 250. So we're just going to put 250 for our size. Okay, so since we're trying to make NaOH, we just look at the size of NaOH we want, which is 250. And that's the size of the flask that we want to make. All right. All right, and then last step for this problem, last thing we need to do is figure out the grams of NaOH we want to weigh out. Because obviously when we do labs and we put stuff on scales, it gives us a number in grams. So we got to find our grams of NaOH. So this part is pretty easy. All you're going to do is, since we're looking for NaOH, we're going to take the moles of NaOH that we found. So this number right here. So we're just going to write down 0.1 moles of NaOH. Since we want to turn it into grams, we're going to set up a fraction. We're going to put moles on the bottom, grams on the top. And if you guys remember, if there's grams and moles, we get the numbers from the molar mass. So we go on the periodic table and add up these numbers. Okay, so I'll do the math for you just to keep it, again, simple for you guys today. Na has a molar mass of 23. O has a molar mass of 16. Hydrogen is 1. So if we add them all together, that's going to give us a molar mass of 40 grams in 1 mole. So we just want to put a 40 on the top, 1 on the bottom, and for your final answer, it'll be 4 grams of NaOH. Okay, so I'll cut it right there just so that you guys can have enough time to work on your assignment. Again, next time we meet, we will be starting the lab. So just make sure that you guys are comfortable doing this, because you'll need to be able to do these types of problems in order to do the lab, because if you don't know how to write the procedures, then you don't have procedures to go off of, okay? All right, that's enough for me. I'll give you guys the rest of the class period to work on the assignment. If you guys got any questions or want to check your answers, please let me know. But yeah, good luck on your assignment, everyone.